Was Lab 3 Black Hole Orbit. The purpose of this lab was to create a computational model of a star orbiting a black hole and using it finding the net force and the parallel and perpendicular components of that net force, and to calculate the mass of the black hole. This is what I got as the mass of the black hole. And this was the net force, this was the parallel component of the net force, and this was the perpendicular component of the net force. The fundamental principles involved were derived from Newton's second law to find the parallel component and the perpendicular component, and we assumed that the only force acting on the system was the gravitational force. This was the predicted motion of the computational model. These are the initial conditions we used, and again we assumed that gravitational force is the only force acting on the system. The arrows show the net force, the parallel component of the net force, and the perpendicular component of the net force. We analyzed the data to calculate the change in position of the star using the data that we got from the Excel file. We used the computations that we made in the previous slide shown to calculate the initial and final velocity and the initial and final momentum. We used those numbers to calculate the net force acting on the star and consecutively the parallel component of that net force. We found the perpendicular component of the net force by using the principle that net force equals the parallel component plus the perpendicular component. I found the mass of the black hole by using the formula for gravitational force, which is, in this case, is the net force. If the mass of the black hole had changed, if it had been bigger or smaller, then we know, and the motion had stayed the same, we knew that this would be an impossible case, because if the mass had changed, this would consecutively change the net force, which in turn, using the momentum principle, would change the velocity of the star and the position of the star. So we know that motion would definitely be different if any of these masses were changed. Net force isn't necessarily the same thing as the change in momentum over time. The forces are merely what cause the change in the momentum, so we can see them as being more proportional to each other than equal to each other. In turn, this affects the parallel and perpendicular components of the net force and the change in momentum over time. We can see this even clearer by observing the change in momentum of an object when the velocity is constant or zero. In this case, the net force is zero, but we can't define the change in momentum because p hat cannot be defined.